Welcome to JAG Learning, the chemistry section. In this video, we'll be going over kinetics, paired along with acids and bases. Okay, let's begin by reading the problem. What is the pH of a solution of saturated magnesium hydroxide with this KSP? Okay, so let's begin by defining what magnesium hydroxide is. It's simply magnesium paired with two hydroxides, because magnesium has a +2 charge and hydroxide has a -1. So for a KSP problem, I would normally start out with an icebox. And we can fill this icebox out. But we should know, with an icebox, you of course need to know what the reaction is. And since this is this solution, since this magnesium hydroxide is separating into its constituents, you just want to write them out like this. Magnesium, 2+, with two hydroxides, because you see here that there's two of them in the subscript. So we can also write that for the icebox, and OH. And an important feature or an important part of this question here is it says a solution of saturated magnesium hydroxide. So when you do your KSP, you can basically just ignore the magnesium hydroxide part, and just instead of products over reactant, you can just put your products. So the products of, see if I can write this a little smaller, products of magnesium times the times the molarity of the hydroxide squared. And since this changes, we don't know the initial. We're not given the initial. At magnesium, the magnesium here is +x, and this is +2x. Since this has a subscript, since this has a coefficient of 2, and this has a coefficient of 1, so 1x, 2x. And here is basically 0 + x, or x plus 2x, and this is equal to your KSP. Or we could plug this into our equation here, right here, to get our KSP. So let's just plug it in. So the solution, or the molarity of magnesium times the molarity of your hydroxide, and you square that here. So you square that. So this should equal, so your KSP equals this, and this should equal 4x squared. So 4x squared times x is simply 4x to the 4x cubed. And this is equal to your KSP, which is already given, which is 1.2 times 10 to the -11th, right? And by setting up this equation, we could simply solve for x here. And solve for x, you divide this, you divide each side by 4, and you take the cube root of both sides. So let's clean this up a little bit to make it just cleaner in general. Let's clean this up. So x is now equal to, what x is equal to is this KSP over 4 and cube rooted, just like that. Okay, and let me just pull out the calculator real quick and see what it equals. 1.2 times 10 to the -11th divided by 4, and math cube root this. And it should equal, x is equal to 1.44 times 10 to the -4 here. And with that, we're not done yet though, because as you see here, we're looking for our pH. So, and what we're working with right now is hydroxides. And so the molarity of hydroxides is, again, you gotta multiply this x by 2 as you saw in our icebox before. So you gotta multiply this by 2, and multiplying it by 2 will give us our concentration of OH, basically. Concentration of OH, so I multiplied it by 2. And we're now given 2.88 times 10 to the -4. You can simply just multiply these digits by 2. Is equal to that. It's equal to this. And to find your pOH, right? To find your pOH, it is simply the negative log of the molarity of your OH. And I'm going to negative log that right now. Negative log of this number right here. And it should equal what the new pH or the pOH should equal is 3.539999. Okay? And you might think, wait, there's no 3.539999 here at all for the answer choices. But the thing is, of course, we're given the pOH, and that question asks us what is a pH as a solution. So simply get 14 and subtract it by your pOH. And that should equal 10.46, which is A in the answer and is correct.